Proton and a neutral atom are located a distance r apart. We're going to find the magnitude of the electric force on the proton due to the neutral atom. Because of this proton, there's an electric field at the location of the neutral atom called E1. This applied electric field causes the neutral atom to polarize and become an induced dipole. This dipole now creates an electric field at the location of the proton, E2. The force on the proton by the atom is given by F equals the charge of the proton times the electric field E2. We know the magnitude of the electric field parallel to the dipole is given by the constant K times 2qs divided by r cubed. The dipole moment of the polarized atom is proportional to the applied electric field E1, given by P equals the polarizability of the atom times E1. The electric dipole moment of the atom is given by the charge of the dipole times S, which is the distance between the two charges of the dipole. So the magnitude of the electric field E2 can be written as E2 equals the constant K times 2P divided by r cubed, and that can be written as the constant K times 2 times the polarizability of the atom times the electric field E1 divided by r. Since the electric field E1 is just the electric field due to a point charge, we can substitute that equation into our equation for E2 to get the constant K times 2 times the polarizability of the atom divided by r cubed times the equation for the point charge, which is K times the charge of the proton divided by r squared. Simplifying that, we get K squared times 2 times the polarizability of the atom times the charge of the proton divided by r to the fifth. The electric force on the proton by the atom is given by F equals the charge of the proton times E2. Now we just plug in the equation for E2 that we just got into this force equation, and we get the charge of the proton times K squared times 2 times the polarizability of the atom times the charge of the proton divided by r to the fifth, and then r hat. And simplifying this, we get K squared times 2 times the polarizability of the atom times the charge of the proton squared divided by r to the fifth times r hat. Now, since neither the proton or the atom are accelerating, the forces they exert on each other are equal in magnitude but in opposite directions. So the force exerted onto the atom by the proton is simply F1 equals negative F2. So the force exerted on the atom by the proton is simply just negative K squared times 2 times the polarizability times the charge of the proton divided by r to the fifth times r hat.